Hi, my name is Will Crawsick, Scientific Services Manager at Chemical Computing Group. Today I'd like to demonstrate the tools that we have in Mo for fragment-based drug design. In this session we'll be exploring the add group to ligand operation, which is a useful operation when we want to grow a ligand into a subpocket or perhaps take advantage of a key interaction with a specific residue. So let's get started. So I'll just open the file that we're working on by clicking the Open button. I'll navigate to the gold star, allowing me to access the sample mol directory, selecting the file that I'd like to use, and I'll hit OK, which prompts this Load PDB file panel. This allows us to select the data that we're going to load into Mo, and here I'll just accept the defaults so that we can see our structure on screen, whereby our structure is coloured by its secondary structure with the beta sheets in yellow, the helices in red, and the turns shown in blue. Now, before we can start thinking about fragment-based tools, the first thing we need to do is prepare this model. It's a raw PDB file, typically with no charges or hydrogens. Perhaps there's also some missing loops. So for that, I'm going to access QuickPrep, our automated preparation wizard, which comprises three main sections. The first, handling the preparation and cleanup of the structure. Second, sets tethers and restraints. And the third, handles refinement. Again, I'm going to accept the defaults. I'll click OK, and I see this progress update at the top left of the main Mo window. I'd just like to reopen QuickPrep so I can explain what's going on in the background. The first preparation stage ensures that we've got a complete model. So what we're doing here is we're adding in missing hydrogens, charges, and side chains. If there are any missing loops in our model up to 10 residues in length, they'll be modelled and grafted in. Protonate 3D optimizes the ionization states of the bound molecules and their side chains, also generating a hydrogen bonding network through the placement of polar hydrogens. By default, we tether the atoms within the active site, and we do that to ensure that we can retain the original geometries of those atoms as they were captured by crystallography. We don't want to lose those geometries to processes such as energy minimization. And likewise, we can fix any atoms that fall outside of the active site, and we can do that for reasons of computational efficiency. The final refinement step performs an energy minimization, and this ensures that we don't have any clashes in our structure. So I see the message has gone from the top left of the main Mo window. It tells me our model is now prepared, so I'll just cancel this panel, and next what I'd like to do is have a better view of the interaction between ligand and receptor. So for that, I'm going to hit Site View. It isolates the ligand together with any residue within 4.5 angstroms. And next, I'd like to adjust the rendering of our system. So for that, I'm going to open the System Manager and pin that to the main Mo window as a means to manage all of the data that we have in our system. From here, I can hide and show different atom sets, I can make selections, I can also render and generate surfaces. So here I'm going to use the System Manager to hide our ribbon, and I'm also going to colour our ligand a bright colour, allowing it to stand out. So with that, our system is prepared. Now I'll just adjust the view of the hydrogens on the ligand only. So I'll select the ligand, and I'll just toggle to show me all of the hydrogens on that ligand. And now we've got the system set up for scaffold replacement. And next, what we'll do is explore adding a group to a ligand, which is a useful operation when we want to grow the ligand into a subpocket or perhaps pick up an interaction with a key residue. In order to work out and further explore key interactions within the active site, I'm going to generate some surfaces. So I'll go to the surface menu and you'll see some of the default surfaces that we have available. I'm going to generate a receptor surface to give me an idea about the size and the shape of the binding pocket. So the receptor surface is coloured by its atom colour, predominantly grey for the carbon, but we pick out blues and reds for the oxygens and the nitrogens. And this particular surface is useful in identifying hydrogen bonding opportunities. I can identify those from either cyan or white patches, and here's an example of a white patch utilised by the existing ligand design. White represents the polar hydrogen, so as I say, this one's been utilised by the existing ligand. But conversely, on this subpocket, I can see we've got several cyan patches. The cyan patches show me lone pairs, so perhaps there's scope that we could pick up an interaction around this pocket somewhere. In order to get a better view of where I can make a substitution on our ligand, I'm going to use Ligand R-Vectors. So when I toggle those on, they'll display these green arrows on our ligand, showing me where I can make a substitution around the size of a methyl group, but without creating a steric clash. And I can see here we've got an R-vector, and it's pointing towards some of these lone pairs here. So let's see if we can create a novel interaction in this subpocket. So for that, I'll need to access our fragments suite, and here you'll see some of the operations that we can perform under the umbrella of fragment-based drug design. So we're going to be doing the add group to ligand operation, which opens our panel comprising 4 main sections. The first allowing me to define the system in terms of ligand and receptor environment. The second allows me to choose the type of operation to perform, and here you'll see the same options as we saw within the compute menu. The third allows for filtering, so I can add in 2D or 3D filters, and the final part of this panel handles minimization and scoring. So if I just move this panel to one side, and I'll go ahead and follow the prompts of this panel to help set up the run. So it's saying to select the hydrogens to mark a connection point. So I'm going to take the suggestion of the R-vector and use this one here. And as soon as I select it, you see in the panel, I've got one connector, and since there's only one, that would be the essential one. I'll move on and look at the filters of the panel now. So I see that by default, we've got some default descriptors that have been added in terms of a molecular weight cutoff, a TPSA range, and a note on reactivity. I also notice, though, that the Check Filters button is coloured red. If I just hover my mouse, Bubble Help tells me this button is coloured red if the ligands do not pass the descriptor filter. To understand why our ligand might not pass the descriptor filter, let me just click on the Check Filters button, and it gives me additional information here telling me that the weight of our current co-crystal ligand is 528, and you'll notice here the default cutoff is 500. So this is indicating that, especially since we want to grow our ligand, our current co-crystal ligand would not pass this filter. So let me just manually type and push that up to 600, and notice that the Check Filters button is no longer red. Here I'm going to opt to use another filter, so a Pharmacophore, which is going to allow us to encode the type of interaction we'd like to see. So here I do have the option to load in a Pharmacophore, but I'd like to open the Pharmacophore Query Editor here so that we can generate one on the fly. So the Pharmacophore Editor will allow me to add, remove, and modify query features from either the receptor, the solvent, or the ligand, and those features will soon be populated at the center of this panel. If I just move that panel to one side, I notice that the ligand has become annotated with these annotation points. And these are color-coded, such as we've got our acceptors shown in cyan, we've got donors in magenta, aromatic in orange, and hydrophobic in green. Notice that some of these annotation points don't sit directly on the ligands, so these are projected annotation points, and they give me an idea about directionality. So in this case, I'm going to look for an interaction with the receptor environment. So I'm not going to display my ligand annotation points. If I just toggle those off by clicking the L button twice, I'm going to look at the receptor annotation points. So I'll just turn those on. And I can see that we've got a donor up here, which is seems to be pointing towards or more to the point, the R-vector is pointing towards that cyan patch that we see. So let me just select the annotation point, go to the Pharmacophore Editor and generate a feature there. So this is specifying that we'd like to see a donor interaction somewhere within this 3D sphere in this space. So if I just go back to our panel, I'll just need to reselect the hydrogen now because I've just deselected it whilst doing the Pharmacophore. So I'll just reselect that, and again I see connector 1, essential 1. And now I'll move down the panel. This time I'm going to opt to minimize the generated structures within the receptor environment, and I'd also like to write a score to the output database. So I'm going to select GBVIWSA, it's our default score, and with that I'll initiate the search by clicking Search. So in the background, Mo is now searching for linkers that are going to grow our ligand from this connection point, but looking for interactions with the receptor as we specified using the Pharmacophore. You'll notice that we're minimizing our structures within their receptor environment, so we're going to get the energetically favorable poses of our structures. And we'll also be writing the GBVI-WSA score, which is going to allow us a quick method to prioritize which fragments or structures that we'd like to further explore. So in the background, Mo searches a linker and fragment database containing just over 40,000 structures, and those newly generated results are written to the database viewer. This would be our third major window type in Mo, which we use to display database entries, and in this case, database results. It looks and feels like an Excel spreadsheet, but if I just drag the mol field open, you see that it actually contains the 3D structure of our ligands. This would also be our launching point to various tools that we have in Mo. So for example, we could jump into QSAR from here. So you notice within our database viewer, we get our newly generated structures. And if I just scroll along, we also get the GBVI-WSA score as if these structures had been docked to the receptor environment. Now we've already generated a number of structures and I get a progress update. I'm just going to prematurely stop this search so that we can have a look at the results. So the reason for writing the score to the output database allows me to prioritize my results. I can sort by any of these headers that you see in the database viewer by right-clicking. If I go to sort and ascending, it'll ask you, sure you want to do that? I click yes, and now I get the best scores displayed at the top of the database viewer, and they progressively fall off in terms of their score. This being an energy, the more negative, the better. Beyond looking at these numbers though, I'd like to get an idea of how these newly generated structures look in the receptor environment. So for that, I'm going to open a browser, which allows me to view our newly generated structures both in 2D and within the 3D receptor environment. I can write any of these fields to the browser, so perhaps I'd like to keep track of the score, and I can have that displayed on the browser as well as the top left of the MainMo window. And within the MainMo window itself, I can see that we've got our newly generated structure shown in green against our original co-crystal structure in magenta, and from here I can cycle through to have a look at some of those newly generated structures, each of those having an interaction with the Pharmacophore as we requested. So let me just close the browser and I'll bring back our panel. That brings us to the end of today's session, where we use the add group to ligand operation to grow the ligand and take advantage of an interaction within a subpocket of the receptor. We also minimized and scored our newly generated structures in the receptor environment. I hope you've learned a lot today. If you have any questions, please do reach out to me at support@chemcomp.com.